So, oh, it did it. All right. Sweet. So, regular old design here. I've got my 50 students, and biggest thing here is I want to have good, I'm going to split them into two groups. So I've got, where's my groupings? I've got online, or they're in the classroom. And so I'm going to randomly, I'm going to point out in my experiment that I'm going to randomly group them into those two groups. So
would you do 10 seniors and 15 juniors?
So we're actually not going to do that just yet. So we're going to completely randomize design. We're just going to split them into two groups. So group 1, group 2, and there's 25 in each. And I randomly assign. And so random assignment, again, is like use a calculator to label all the students 1 through 50 and get a sample of 25 and group them into the first group. The others go to group 2. And then, okay, so I'm going to split them into two groups. Let's say these people do the online, online SAT. These people do the classroom SAT prep. And then you just simply carry out your two different treatments, whatever you're doing. And then I'm going to compare like SAT scores in the end. That's like what our response is still. Our response is what is the SAT score. So compare SAT scores. Alright, so that's your basic experiment. So just take everybody, randomly assign to group 1, group 2. Random assignment will hopefully split people who have they'll study more into both groups. You've got seniors in both groups, juniors in both groups. If you're just randomly assigning it, it just kind of does the trick. All right, but maybe we're looking for a little more. So step number 2, the counselors hypothesize that online versus classroom could be greatly affected by grade level of students. So they know that seniors generally score better than juniors on the SAT. How can we adjust our experiment to ensure that there is an even split of seniors and juniors? Draw an outline. So this is called blocking. So this is like a randomized, this would be called a randomized block design. So it's kind of like strata. They're pretty similar, but blocking is for experiment and strata is for sampling. So it's different. So I take my 50 students. So I always start here at the beginning. And then I'm going to split them, not randomly, but into, what was it, 20 seniors? Yeah. 20, wow. Okay. All right. Let's see if that happens again. 20 seniors. Okay, I don't know how that happened. Oh, there we go. I went cursive all of a sudden. Let's see if this works. 30 juniors. Well, that worked. Alright, so that wasn't random. I want to split because I think there's a difference between the two. So I split them, and that's called blocking for an experiment. Strata for sampling, blocking for experiment. And then I'm going to randomly, assign, what the heck? That's not my handwriting, that's the...
Maybe you need to calibrate it.
I don't want to calibrate.
It literally takes 12 seconds.
I know. Randomly assign into online versus classroom. Yep, I need this. It's a great day to be alive.
So this is the part in the video where I just skip and move on.
This is when I would make sure it's on 2 times speed.
Yeah, 2 times speed, and then you just skip.
Just like Coach Reese's video, it took 2 hours to watch one.
I can also.
Look at that. Classroom. Okay. Same thing for here. I'm gonna make sure I'm pointing out that I didn't just put them. I'm letting some random number generator randomly assign into online class versus classroom. So blocking is just first we purposely split them on some characteristics, then we carry out the experiment, and then I want to compare between like seniors online in classroom, compare between juniors in online classroom, and then I want to compare between seniors and juniors. Like, so my overall comparison could be something like, you know, oh, the seniors did better online, while the juniors actually scored better in the classroom comparatively, like their SAT score. So in the end, I compare in the groupings individually, and then compare overall. So comparing everywhere. Yep.
What are these graphs called? I forgot. They have a name, but I forgot what they're called. Like the.
It looks like a tree diagram, but that's not what that is.
I remember learning in Aggie Math, but. Yeah.
We're gonna do tree diagrams in like a week.
Oh,
Yeah, we'll do that.
okay.
In probability, but yeah, that's not quite what this is. This
Yeah.
is more just like a flow chart. Like I'm splitting, and you just kind of split
okay.
here. Yeah.
So it could, if, like in the AP test, could we answer like this? And
Yep.
then count? Okay.
Mhm. Yep. All right, so that's a block. Blocking is like stratification, but it's for experimenting. And then we're purposely splitting on something that you think is affecting the difference. All right, here, number 3 though is one more type of experiment that we have. Counselors are now worried that students' GPAs are certainly going to affect their SAT score. Like, if you have a high GPA, you're probably more likely to do better on the SAT. Let's look at only juniors, and we want to be sure that the different GPAs are being evenly distributed between the two groups. So I want to make sure I have like the top 2 highest GPAs split into the 2 groups. The 3rd and 4th highest GPAs split into the 2 groups. Like they're not all grouped together. How could we ensure the GPAs are evenly distributed? So this one is called, wow, a matched pairs design. So this is an experiment. It's called matched pairs. And a matched pairs design can be, we're gonna do it with different people, but it can also be like the individual themselves. Like, I get your SAT score, you take it on your own, then I put you through this SAT prep class, and I get you to take it again, and I compare your SAT to your next SAT after. That would be a matched pairs as well. The way we're gonna do this one is, let's see, we're looking at juniors, and so we're gonna like rank people by their GPAs, and we're gonna make sure we split them into group 1, group 2, like the next person, group 1 and group 2. So, yeah, I didn't make a flow chart, I just kind of wrote it out. I thought it'd be easier that way. So what I did is I just said, rank students in order of GPA, and you can do like highest to lowest, whatever. So highest to lowest. And then, so what I'm gonna do is like, the first thing would be, like, take the 2 highest GPAs. So take those 2 students with the highest GPAs, and whatever, you could use a calculator, use a digit table, you flip a coin to decide which group do they go to. Do they go to the online SAT prep or the classroom? So take the 2 highest GPAs, maybe I'll say calculator. Use calculator to randomly assign one student to online prep and the other to classroom. Okay, so I do that for the top 2 highest GPAs. I do it for the next 2, the next 2, the next 2, all the way until the bottom 2 GPAs. And then what that's going to do is that hopefully just split everybody together nice and evenly. So both the groups are really split up. So well, I guess I'll say repeat this for, I don't know, the next 2 GPAs until you run out of juniors. I said repeat this with next ranked GPA students until you run out, basically, until you have split everybody. So that's kind of harder to do in like a flow chart to explain. So rather just write it out. So in basic form, it's just like you can do it on anything. If I think like we're gonna split our classroom up right now into like, I don't know, like a basketball game or something, a volleyball game. Maybe we'll do volleyball. But let's like take out. Or you can even do that, like, let's say we do like a volleyball, and maybe instead, what I was gonna do was like split people or rank people like lowest to highest in height, and we wanna make sure I have tall people and short people all mixed together. I don't wanna accidentally have like all the tall people playing volleyball together versus all the short. Maybe though, it's like skill level, like rank yourself on like, have you played volleyball before, 1 to 10. And we split like Alethea and Megan up because they've played volleyball, and like we split like the lowest, everyone up gets like switched up into like the 2. So you can do that with anything. We're just trying to split people evenly, whatever the game or group is. So rank people who are similar to one another and make sure they get split into the same groups. You can do that with like ages too. Like I'm gonna group a 20-year-old female with a 20-year-old female, and they're gonna split into 2 groups. And an 80-year-old male and an 80-year-old male, and they get split into 2 different groups. Right? It's just to try and make sure that these groups become as even as possible. So that's matched pairs, and matched pairs is also when you do it with yourself. Like I've got your own test score, I put you through the trial, and then I get your own test score again. That's matched pairs. So you got 3 different things, just like your basic design, you've got block design, and then you've got matched pairs. Okay, so that's kind of the main idea. So, yeah, big idea. I guess I'll make a little list here. Block, match pair, and then you can also just do completely random, which is the basic one. But so blocking is, what I said, separate into like groups that you think have an impact. So into groups you think have like different outcome, and then you carry out like your experiment inside of those groups. So then, what did I say? So then assign treatments within each group and then compare. And then matched pair would be like two similar. I just don't want to always say like people, because you can experiment on anything. So more like two similar, you could say like units or whatever, like people are units. So split, so two similar units are paired and then randomly assigned into each group. So then repeat for whole sample or for whole experiment. So kind of, we didn't do it on that one, but the other thing is like also a match pairs design is when you're comparing yourself versus yourself later. So also can be comparing like that same person to themselves. So I don't know how to exactly say it. Comparing same person to themselves. Like that could be an example of I give you a test and I just told you to do your own normal thing, and then I'm going to give you a test a couple weeks from now, and I told you to take 30 minutes every night to like review notes, do your homework, like spend each night 30 minutes on statistics, and then take the test and compare your test versus your test, your first test versus second test, and do that for every single subject. So that would be also another match pairs design. Alright, so blocking, match pairs, all this good stuff. Alright, let's see. So, an example, just so we can do another one here. Researchers would like to design an experiment to compare the effectiveness of 3 different advertisements for a new TV series featuring the work of Jane Austen. There are 300 volunteers available for the experiment. Describe a completely randomized design to compare the effectiveness of the 3 advertisements. So this is where we can just draw out a flow chart. So a completely random design is we just take everybody that we have. So we've got our 300 people. And let's see. So what we're trying to do is we're treating them with three different ads. That's like our treatment. And we're trying to compare how did those advertisements work? Like, I guess, are they going to watch my TV series now? So I've got these 300 people, and I'm going to 300 people, I've got 3 different TV ads. So I need to split them into 3 groups. So I'm going to make sure to say that I'm randomly assigning them into group 1, group 2, group 3 with like 100 people in each. And then, I don't know, group 1 gets ad number 1, group 2 gets ad number 2, group 3 gets ad number 3, and compare effectiveness of ad. So that's just your basic design. Alright, number 2, a block design for the experiment. Justify your choice of blocks. So I want to split people into some sort of group that I think will have a difference on, like, are they going to watch this Jane Austen TV series?
Could you do age?
Age? Okay, yeah, like maybe older people want to like watch her versus others. That's not a bad one. Age.
Gender?
Yeah, maybe, I don't know, maybe gender. Whatever you do, if you split on age, gender, whatever, you just need to be able to say, like, this is why I chose that. Like, I think females might want to watch this woman work with monkeys more than males. Like, they're just not going to want to watch this. Whatever. Like, whatever you think it is. So, what I did, is I took our 300 and so what I did is I split them based upon did they already know who that person was or not.
Oh.
Like, you can do age, that's fine. You can do gender, you just need to like be able to at least argue for it. But I just said know who Jane is, don't know Jane. Because if I already know who she is, then I'm probably more likely to be like, oh yeah, I want to watch that. That'd be awesome. Sweet. Glad they're doing a documentary on it, or whatever. Who knows? So, whichever one. And then, within each block, I'm gonna do ad number 1, ad number 2, ad number 3. And then same thing down here. Add number 1, add number 2, and add number 3. And I'm going to make sure that I'm randomly assigning those into those groups. And so then, like, inside of here, I'm going to compare. Inside of those, I'm going to compare. And then overall, I'm going to also just see what happened. Just point out some characteristics of those. So, ad number 1 really worked with the people who already knew her. Or if it was age, it worked. Ad number 1 worked with the like 60 and up population really well, but ad number 2 worked with the 20 and below population. Like, whatever, you can do it that way. Alright. And then why might have our randomized block designs be preferable in this context? So this is kind of like stratified and cluster. Like those stratified is probably the best sampling method, but it does take the longest. So it takes the longest for us to be like, let's split these people up. Sometimes it's not very easy to split people into groups and get their stuff. But why might this be preferable? It's always gonna like reduce the spread, the variability of like the advertisement, because on this top one, like I might have accidentally got a lot of people who knew who she was in this group just by randomly splitting them. And maybe a lot of people didn't know her in group 3. So why might randomized block? So basically blocking ensures that I have, and I'll just go with our example. I have people who know Jane getting all 3 ads, and people who don't know. So people who know Jane seeing ad 1, 2, 3, and people who don't. And then that's just gonna reduce, so it reduces variability of answers. So like it can really hone in on like ad number 1 really was the best, compared to ad number 1 might have been the best because I accidentally had a lot of people who knew who she was in that grouping. And then the next time I did this study, ad number 1 didn't have a lot of people, and so all of a sudden ad number 1 had a really low rating. Like whatever it is, I just want to have an accurate answer. I don't want to have like a big standard deviation, a big spread, and so I want to have a really concise, like, this is hitting consistently, experiment after experiment. Ad number 1's the best. Like I want to have an experiment that's kind of hitting the mark consistently. Alright. So that's kind of the gist there. Got blocking, match pairs, just a regular old experiment. What we're trying to do with these two is, well, we could say like cause and effect, but we're trying to reduce any confounding variables like, oh, these people, those are hard to control though. Like, oh, the person did better on the SAT because like they actually got 10 hours of sleep the night before, and it turns out a bunch of these people like went to the homecoming football game right before then, and they didn't get home until 1 a.m. or something like that. Whatever. Okay, that's block design. That's experiment. So what we're gonna do for the second half is there's the quiz on Schoology, and what I want you to do is I'm gonna let y'all kind of brainstorm together on it, and kind of work through those. I can give you the paper copy. I do want to explain one thing on here, on there. It talks about what are your experimental units, what are your factors, and what are the treatments. So your units are just like, who are you testing? Your factors are like, what are you doing? Like, I'm doing this to the people. Like, I'm gonna give them pill number A. So like, what are you doing? And then the treatments are like exactly what would this group get, what would this group get. So the treatments are like a list of all like types of treatments. Like I'm gonna give them This group gets Coca-Cola, this group gets Dr. Pepper, this group gets Pepsi, and this group gets RC Cola. Which one's the best? Like, that's like your treatments. Your factor would be me giving them different types of soda and wanting to know who's best. And the who would be my AP statistics class or whatever. So that's kind of the difference between those two. We just hadn't really talked about factor in a word. Yeah, so I want you to look at the quiz. Here in class, we've got how much time? Lots of time.
Is it resistant?
Lots of time, 40
Or
minutes.
is it a paper copy?